Thank you very much, Professor Wilson, and thanks to Dr. Paul Dykstra for the kind invitation to come here today and discuss what I feel is a relevant topic, and especially when regarding non-contact lower limb injuries. Okay, we feel it's relevant because once you get to a certain level of competition, an organised level of competition in football, you'll have to pick a shoe to use. Okay, and you'll also play on a surface that has generally been prepared by some ground staff in some way. And maybe we don't put too much thought into how we choose the shoe or how that surface was prepared and in what way that might influence injury. So, given the wealth of experience and knowledge here today, with regards to football medicine and the rehabilitation of players who are injured while playing football, this probably seems like a reasonably bold statement, that it does influence injury risks. So let's have some fun and see if I can back it up. So we know from the excellent work of Dr. Cristiano, who didn't go on holidays early and is here. In 2013, he did a fantastic study that showed us that the incidence of injury in professional football in Qatar is really very high, especially with regards to anterior cruciate ligament injuries and ankle injuries. And my question is, at what cost do these injuries come? From Cristiano's work again, we know there's a cost to the team. Teams that have the most injuries tend not to do well in the league. Teams that have a low injury rate tend to do quite well. So that makes sense that if your players are available, they should be fresh and they should be able to compete and do well. We know from the work of Professor Ekstrand and his UEFA injury studies that there's a financial cost to the clubs, somewhere in the region of 500,000 to 600,000 euros per month, every month that player is missing from football. But I'm really interested in the personal cost. What are the long-term ramifications for this player? There's good evidence now to suggest that if the player has an ACL injury or an ankle syndesmosis injury, that they will most likely go on to develop osteoarthritis. And so prevention really becomes key. How can we prevent these injuries? I think great inroads are being made with the prevention programs like FIFA 11 Plus, the Nordic hamstring programs and these things. And they heavily rely on compliance. But what if I could tell you about something that you could take back to your clubs today or your places of work if we just think a little bit more about the shoe that they select or the surface that they play on? And it can have an effect of 2.5 times, so it can influence injury rate by up to 2.5 times if we get this selection right, if we can marry up this shoe and surface. And that's what I want to do today. So serendipitously, or by chance if you like, this is our paper on the front cover of the British Journal of Sports Medicine, this latest edition. So it just went on in the last couple of days. Mostly, I think, because a very prominent sports scientist designed a lovely infogram for us, and I think green probably looks quite nice. I'm not sure if it's completely to do with the quality of the paper, but I'll let you be the judge. What I want to go on to discuss is this shoe surface interaction. This somewhat modifiable possible risk factor for lower limb injury. We all know about the non-modifiable factors, the advancing age, gender in some cases, a history of previous injury. But what about these things we can tune or we can possibly change? Okay. Just as a side note, if I mention references, they're all from the introduction and discussion of this paper, so we can provide a PDF, no problem for those interested. This is the actual name of the paper, and my co-authors, Dr. Chris Bleakley, who's a physiotherapist and injury prevention researcher, and this Paris model here, who you'll all be aware of, is Rodney Whiteley. Okay. So, first, if we have a look at how all this started, how we started to think of this interaction between the shoe and the surface. I was about 2 weeks in Doha. I'd left my family behind, as you do, for the first couple of months, which is why I was actually allowed out in the evening here. Nadal had just finished playing, and everyone obviously goes home after Nadal plays, so we snuck down to these expensive seats in the boxes, and my iPhone picked up something quite curious. I can let you listen and watch, and if someone feels brave, they can let me know what they think they're hearing. So that's the end of the point. Anyone feeling brave? What do you think we're hearing? Yeah, the shoe on the surface, the sole of the shoe. But in particular, do you think that, what do you think that noise is? A sliding, yeah? Friction, great. I think it's friction. I think we're hearing the force that resists motion between the shoe and the surface, and friction really gives us an idea of how that shoe is decelerating on the surface as he's sliding in to hit the ball, and then he accelerates again. So friction's a resistance of two bodies to movement. So we have to overcome that friction, or if we're moving, friction acts to slow us down. Okay? So the reason I liked it is they're invisible, aren't they, these forces? We don't think about them that often. My phone picked it up, but we can't see them as we can see kinematic changes or big joint angle changes. So maybe we don't think about them so often, but they are important. So we take that onto football. We have our cross-section of lovely soil and grass surface here. Player with his football shoes trying to perform a task. And as that player pushes on the surface, he'll generate force. So he'll push on the surface, and the surface must push back. It will do that in different directions, in a horizontal direction, a vertical direction, a resulting direction. But we require this surface to push back on the player, and that's how they generate force. We know that a certain amount of friction, or traction as it is known in studded footwear, so if we have shoes that have studs or cleats on the outsole, tend to call this relationship traction. Okay? And we know that a certain amount of traction is required so that the player can push on that surface and not fall over. So think about if he tries to do that on a very icy, slick surface, or there's banana peels all over the surface or something. It'd be very difficult to generate force. Okay? But the question is there a window of traction? Okay? Too little can be a problem. But what about if we go too high as well? Is that an issue? This relationship of traction tends to be broken up into two components. The straight line traction, which is running back and forth, accelerating, and side-to-side type of traction, known as translational traction, sort of linear or translational. And then we have rotational traction, where the player is cutting or pivoting, and the studs of the shoes have to release from the surface. They have to be able to turn through the surface. And this rotational traction is the one that's often implicated in injury. Okay? The reason being, it's postulated that an increased amount of friction between the shoe and the surface, at the playing surface, can cause a foot to become trapped in the surface, or trapped on the grass on top of that playing surface. And the rotational force then is shifted more proximally to joints like the ankle and knee and so forth. Okay? Some great work by Mark Drakos and team put a strain gauge inside the ACL of some cadavers, and they used different shoe and surface combinations to rotate the leg of the cadaver with the strain gauge in and see which generated the most strain. And it was found that certain shoe and surface combinations produced more strain on the ACL. And we know there's shortcomings with cadaver studies, there's no neuromuscular input and so forth, but it certainly provides a biomechanically plausible explanation for why there's extra strain with extra friction. Some other great research by Dowling and colleagues found that the surfaces that have the higher friction tend to incur changes in the movement strategy of the players. We get strategies that involve higher knee valgus moments, and knee valgus just means the knee shifts inwards with more force. When players cut or turn, they tend to put their foot further away from the center of mass, and they may have less knee flexion. And these things have been implicated before for ACL injury risk. Okay. So if these things are important, can we measure them? How do we measure them? How is it currently done? So I want to run quickly through what the governing body of football recommends, FIFA, at the moment, and they align closely to the governing body of rugby union. The NFL or American football have their own standards, which are quite similar, just using different machinery. So we'll quickly go through and talk about the tests for these two components, the straight line and the rotational. They can be found online in a handbook that tells you about the testing methods and tells you about the ranges they expect the surface to be in. So the first test is a pendulum-like device that swings down, okay? And this is for the straight line traction. And what we have is some studs on the bottom of the device and an accelerometer. And as this device swings along and skids over the surface, it decelerates through the grass, and we get a range in Gs. So FIFA suggests between 3 Gs and 5.5 Gs for an international pitch. The majority of players, I think, that I speak to prefer this to be on the upper limit. They want to be able to feel that they can accelerate off the pitch, okay, and that's straight line traction. The question is there a level above which increased performance does not continue to improve, but injury likelihood becomes more likely? And this is for the rotational traction. This is a FIFA-approved device. This is over on pitch 7 in Aspire zone. What we have is a disc that has some studs on the bottom of it, okay, and weight. This is dropped from a set height onto the pitch, and the whole assembly weighs about 46 kilograms. At the top, we have a two-handled torque wrench, and the wrench is turned, and it gives you a reading for when the studs tear clear of the surface. So as those studs tear through the grass, we get the peak amount of force. This is called, it's a rotational force, and it's known as peak torque. So like torque in a car, any turning force is measured in torque, and that's measured in Newton meters. FIFA again give us a range between 30 and 45 for their pitches. But it only tells you the maximum. It doesn't tell you how the force is developed along the way. It just says, well, that's the end result. This is where we do these tests, so you do them all over the pitch in different areas. We know that there can be different wear in heavily used areas, and so is there different rotational traction here compared to here, and we need to get an average for the whole pitch. Some excellent work by Twomey in Australia looking at Australian rules football has really started to ask questions about the reliability and the repeatability of the measurements by this disc, by the studded disc apparatus, and also how it relates to how a player would feel the loads. You know, it drops straight down and we turn it. The studs are not very similar to they would be on a football boot. But it does keep the studs constant so that we can test on different surfaces. So if we have the studs constant and we look at a grass profile like this is, say, ryegrass, which is grass that's commonly used in Qatar in the wintertime. Okay, it grows fairly straight up and has reasonably low traction. Okay, and imagine in summertime in Qatar, and we have this grass called Bermuda grass, which has all these gnarly root system and very clumpy and very thick, and it's what's called thatchy. So the grass roots grow very laterally and become very dense. Okay, so some great work done by Dr. Orchard, John Orchard in Australia, who does a lot of shoe surface type research, has found that the ryegrass is associated with less ACL injuries than the Bermuda grass. And so from this, we know that grass species, the soil mixtures, and all sorts of things can alter the traction on that surface. And there's great plans here with the head of sort of turf management in the Aspire zone here, Mr. Wayne Holmes, to grow different plots here leading up to the World Cup with different soil mixtures and different grass species, and then test these different traction parameters, which is a fantastic idea. Okay, so if we take our disc with the constant studs and we test the ryegrass that is used in the wintertime here, and we get the peak torque, and then test the Bermuda grass, which is used in the summertime, we have quite a difference in rotational torque. Okay, the factor that's generally implicated in injury. So I think this is the information that we need to be sharing with the medical teams and players so they can tune their footwear selection in to what's happening with the surface. It's difficult in Qatar in summertime to find many different types of grass. There's two that they're trialing in the Aspire zone at the moment that will put up with the difficult conditions. So we have to let them know that this is how high it can be, and accordingly, if that's a very high friction surface, we need a lower friction shoe to find that optimal window. We can't have a high friction surface and wear very long studs and very high friction shoes. That's going to take us above what is that nice optimal window. And I think this is why it matters. So what we have here is a player at Liverpool on a wet night on a natural grass pitch with long studs in, not expecting a change in friction, stepping over onto an artificial pitch with a higher friction, and the studs are getting stuck on the surface. So I think there's certainly a neuromuscular element here. There's a cognitive task, like Darren Paul talked about. He's looking at the ball. There's possibly players pressing from outside the picture, and he doesn't see that change in surface. Okay. So that was about the surfaces. How can we tune this footwear selection if we get the information? Firstly, where do we begin with footwear? This is where we started, these heavy boots in which these were the studs. You couldn't change them. That's what everyone played in, and that was the status quo. Adi Dassler came along and designed a soccer boot with interchangeable studs, and the game known as the Miracle of Bern in Switzerland, which was an extremely rainy game where Germany were not fancied to win, but they had these changeable studs that gave them more traction on the surface and better footing, and they beat the favourites Hungary. From that, we've moved on to this. This is Messi's boot. Extremely thin upper, so they have feel for the ball and touch, different stud shapes and configurations, and quite often wearable technology, so we can have accelerometers that track distance and acceleration. It's probably pertinent to ask, what do players expect from their shoes, or how do they select them? Some great work by Edvald Henning, a researcher in Germany, did some large shoe surveys over many years, so 1998, 2006, and 2013. He wanted to gauge what players expect from their shoes and how they choose their shoes over that snapshot in time. What he found was players really rated traction or sure footing. They wanted them to feel comfortable, and they wanted touch and feel. They really didn't rate injury prevention. They weren't very concerned at all with whether they got injured or not, which seems quite strange. And they didn't actually care too much if the boot lasted very long either. Longevity wasn't high up there, so plenty of disposable income, I think. These are shoes that I've confiscated here in the middle of summer. This is an ACL patient that came through that had ruptured his ACL and some baseball cleats. Extremely high traction shoes on extremely high traction surface with the Bermuda at summertime. These are soft ground long studs that are probably 19 millimeters or longer, and again, anterior cruciate ligament injury on that Bermuda grass. I would direct them towards this sort of thing, which is smaller round studs and much more and more of them, which are known to have lower rotational traction. Okay. This got us thinking, how can you measure these things together? So at the moment we're measuring the surfaces with a standard disc, okay? But these clever chaps in Germany have come up with a machine in which we can load the shoe on, and we can use different loading angles. We can take it out onto the pitch, so we can take it to the actual playing surface, load the player's actual shoe on, and get all sorts of information. You'd be happy to know this is made in Germany, but not by VW, so it works under testing conditions just fine. This gives us great information about the rate of torque development, so not just the peak torque, and it also tells us about all the different parameters we'd like to know about. So that got us thinking about our review. This is our systematic review in which we came up with some inclusion criteria and exclusion criteria for what we'd like to look at. We thought, what's out there in football across the board? Not just soccer football, we looked at every code of football to see what has been done so far. We wanted to make sure they were high quality prospective studies, that they at least had this rotational traction data and injury. The device was portable. It made sense that it should go out to the playing field they play on. Some of the devices that are used in the lab may take a disc or a stud and rotate the surface below them or something, a piece of the surface. Doesn't make sense to me. We'd really like to see the actual playing surface. And we're really interested in natural grass, obviously, as the big competitions in 2022 come up. We didn't want lab testing, and we didn't want devices like the studded disc where we couldn't actually put the player's shoe on. We want to know about the surface and the shoe. Okay. So as we worked through, we had a primary objective, which found 3 large prospective studies, and we had a secondary objective, which really just was papers that had information about what influences this relationship. So we're going to talk about the main objective, which is the injury data. 3 studies, they were all 3 years in duration each, they're all prospective, and a total of about 5,000 male American football players. Now these were mainly high school football players, and all the injuries are non-contact lower limb injuries. They had rotation measures and injury data, and we had good quality score index. One of the studies, 17 out of 19 when we scored the quality, so they're excellent studies. Of note, no soccer studies at all. In our other finding, we found soccer studies that tell us about the relationship, and some of their titles mention injury, but there's no injury data in any football studies, which is for me, quite surprising. It's over 300 million players worldwide. It's the most revenue-generating sport in the world, and we're playing catch-up with American football. Hard to avoid these plots if you do a systematic review, but we'll quickly go through them. There's 3 studies, which we have here, and down the bottom is the pooled data. So this is when we put all the injury information together of which players got injured and which didn't, what shoes they were in, whether it was high traction on the measurements or low traction, and the injury data. And in the end, what we find is you're actually over 2.5. You're 2.7 times more likely to be injured if you get this selection wrong and have very high traction, which is quite alarming. So we'll quickly go through the 3 studies, as there was only 3 of them. The first one from 1996 had 3,000 athletes. They made a little measurement device. They actually turned the shoe on the forefoot of the cleats, or the studs, and they had athletes all in different cleats. Apologies, that's the original picture, but just to note, they had these edge-style cleats, which mean the cleats are on the periphery of the shoe. They're quite large cleats around the outside border of the outsole. And then they had some other cleats, and this is an example of one of them, flat, more cleats and shorter. When they measured them, these were low rotational traction, and these were high. What they were interested in were ACL injuries. So they had arthroscopically confirmed ACL injuries. Okay, the low rotational traction group had 4 ACL injuries. The high rotational traction group had a lot. So it actually had 38. So those of you who can count really quickly, I'm missing 2, I realized this morning. But it's a big difference, isn't it? On this side, we have all the other cleats combined. So it's not just versus, there was 3 different cleat types on this side, and on this side is only the edge cleat. So that's how much difference in rotational traction. I don't think they make that particular edge cleat anymore because of this study. On to the second study, which is fantastic work by a very prominent orthopedic surgeon. This is actually from the 70s, so we maybe should have listened a little better, I think. It's a study in which they had 1,298 subjects, and in the first season, everybody played in these long studs. Okay, these are 19 millimeters in length, and there's few of them on the forefoot. In the subsequent 2 seasons, he made everyone convert to these soccer-style studs. So there is, I think there's 14 on the forefoot, and then 9.5 millimeters in length. Okay, and they measured the rotational traction of the long studs and the rotational traction of the soccer-style studs, and obviously it's quite a difference. So no other intervention. Simply, this whole league must play in these shoes for the next 2 seasons after the first season where they took the injury data as well. And what we ended up with is a huge reduction in knee injuries. And it wasn't just the number, it was actually also the severity. They rated the severity of the injuries as well, and he's an orthopedic surgeon, and the severity went down dramatically. Okay, this is the final study from 2013 in MSSE. This is the highest quality study. In this study, they've loaded shoes onto this machine which Adidas made for them, and they tested the rotational traction, but they also could test the straight line traction. They could test how quickly the force or torque develops, so the stiffness of the surface. They gave us details about all the soil constituents and things. This is a fantastic study. These guys are from the University of Calgary. And the great thing they did was they blinded the injury assessors to who wore what shoe when they were assessing injury. So they didn't have any idea who was in which group, which is a great idea. In the low rotational traction group, we had 4.2 injuries per 1,000 game exposures, and they had a steady increase until we got to the really high rotational traction group of 19.2 injuries per 1,000 game exposures. So again, I mean, these 3 studies have definite trends that there is a relationship here. So it's all good, systematic reviews are great, but how can we use them? We can go on to just suggest some things that I think come out of this study. And these are, I guess these are, if you're watching this later on YouTube or something, these are tailored for Doha conditions, really. I think number 1, we need to get better at this. We need to just talk to Mr. Wayne Holmes from Aspire and work out at what times of year does the grass change. When do they cut that lateral, really thick roots down to put the grass on that's less grippy? what are the watering practices, things like this. We can get a lot of information. They take temperature, all climatic information that we may be able to use. This is my seat at the Super Cuppa in Al Sadd Stadium, just near my house, and Perlo doing some incredible set piece work and free kicks and corner kicks and things in which his stance leg needs quite high traction. Okay, but just before the game, they're watering the pitch substantially. It's Doha, the surfaces are firm, and they want the ball to skid across that surface. So this is actually for the ball to make playability really good, but it certainly affects traction, and I guess it affects it from an injury prevention point of view really well for us, because players will probably slip before they generate enough force to rupture their ACL. However, when is a slip acceptable? What we have here is the last game of the season where Steven Gerrard falls over, Chelsea score a goal and Liverpool lose in the English Premier League, effectively because of a slip. So I think we need to ask, when do we roll the dice? When do we accept the injury risk? This is the last game of the season. The English Premier League's riding on it. Probably, I imagine, a huge financial bonus for these guys. Do they accept that risk if they're well informed? Should you wear the longer studs, the higher friction, and accept the injury risk? If this is a pre-season game or non-skill-based training session, why would we accept the risk then? So when do we roll the dice? If they're informed, they can make a decision. Okay. So our suggestion, and from the secondary findings of our study, when we look at the factors that affect traction, these shoes with smaller, lower studs on natural grass surfaces always have lower traction in all conditions, whether the soil is sandy, whether the climatic conditions change, these are lower. So if it's a non-skill-based session, especially in people who have had history of metatarsal issues and things, these change the loading rate, but they also decrease the traction. Okay? If it's skill-based sessions, then even artificial ground, these are made for 4G pitches and things, but Doha conditions at the height of summer when it's firm and the grass is that grippy, these are completely acceptable and tailor-made. So we have all these small little round studs. I'm not talking the upper of the shoe, I'm not too fussed on, but we're concentrating more here. Okay. I think a tailored footwear program is a very good idea. Some great success by a podiatrist in Australia with professional football teams, and he got players to rate how comfortable they felt in their shoes after training sessions and how comfortable their lower limbs were. They had a program where they used education and they had subject-specific tailored kind of selection of football shoes. So they used in-shoe pressure analysis to select boots and things. The guys who were uncomfortable got injured a whole lot more than the guys that said they were comfortable. So this kind of follows on for great work from a fantastic biomechanist, Benno Nig, that really says comfort is what it's all about. If we can get these, it makes sense, doesn't it? If you're comfortable, you should perform better. So if we just take one simple parameter, and this is a Belgian football team, and this is just their foot anatomy, so one simple sort of, the shape of their foot, there's no way we can select one shoe for all of these players. We can't say you have an agreement with this footwear manufacturing company, that's the best boot, there you go. And if we look at all the different lengths of cleats or studs, the different placement of them on the outsole, just through pure anatomy, they're going to load these people differently. Okay, so my suggestion is, if possible, if you can, we're here, there's 3 of us, use us if you have any questions. We have in-shoe pressure analysis where we can take players down onto the field, put them inside the shoe and see, is a cleat or stud pushing in different areas? How can we select shoes that is more subject specific for these players? This one's up for debate, and this is my suggestion. Some great work by Sturzing suggesting that if we run a course, an acceleration course, so a kind of functional traction course during training or before matches, in which we try 2 different pairs of boots. So this is probably professional level football. We need a kit man or someone to help with this. Players rate how they feel after the course, so they say that traction was good, that's acceptable, and they can put on a rating and then select the boot. When I discussed this with Dr. John Orchard, he suggested that players will always go for the higher traction. They'll always want that traction. And I'm not convinced. I would really like to do further study in this, because I think the expert players have such good intuition and feel that they might know when they're actually bumping along that upper window. And they may actually occasionally surprise you and say that feels too grippy. Time will tell. This is kind of new. If you have players that are playing in summer, you know the temperature is high, which makes the friction higher. You know that the grass is that thatchy grass and things. Please don't let them go out in these things. We don't want these very long, aggressive peripheral cleats, and we don't want these long 19mm plus studs. They go straight down into the surface and require much more force to then release. Okay, so I think as a rule, summertime, let's try and educate players. I take these off players all the time here. This is just a little synopsis of what we talked about. And probably the big thing is edge cleats in DOA conditions, which suggested not a great idea. Thank you very much.